What I did want to go ahead and talk about was just about the AP exam. And again, this is in if you're looking for the tab, AP review, and then exam info. The Calculus AB and BC exam are going to be the same format, obviously different questions. If you're taking it on May 4th, it will be an 8 a.m. exam. If you're taking it in June, digitally, it's basically the same format, but you're not able to go back and change multiple choice questions once you answer them. For those of you taking it in May and in June, it's going to be, like most AP exams, a multiple choice section and a free response section. And then each section is then subdivided into a part A and a part B. I did want to talk a little bit about the parts that you have. So the multiple choice section, the first part is going to be section A, and it will be 60 minutes and 30 questions. No calculator, so a lot like the questions I have on the 3-page binder. After that hour ends, you'll move on to section 1, part B, which is going to be the calculator active, meaning that some, but not all the questions will require a calculator. They will be impossible to do by hand. And you will have 45 minutes to do 15 questions. You can kind of see the pacing there. You can do the easy math. The no calculator multiple choice, you're kind of averaging 2 minutes a question. Some obviously will take more, some will take less. The calculator active section, you're averaging about 3 minutes a question. So they will be slightly more difficult. You are going to have to work pretty fast, though, to kind of finish. And that's one of the challenges, I think, with the exam. Then you will have your breaks. That's going to be like the restroom break, stand up, walk around, break. And then you're going to move into section 2, which is divided again into 2 parts. It is going to be done a little bit differently. So when you first start, you're going to have your calculator with you still. And you will have 30 minutes to do 2 free response questions. That 30-minute will end, and you won't have a break, but basically the proctor is going to tell you to put your calculator away to basically break the seal. It will be like in a plastic bag for questions 3 through 6. And then you're able to work on all the free response questions, including the first 2. You just can't go back to your calculator after those 30 minutes. So we will kind of talk about it a bit closer, like making sure we pick out like which ones will need a calculator, which one won't. Because basically you only have a calculator for 30 minutes, and then it goes away, you can't go back to it. And then when it comes to your grade, half the grade comes from the multiple choice section, and half the grade comes from the free response section. They're evenly weighted with each other. Yes?
How many parts are there for free response question?
The free response question is not set in stone. I will say it's never more than 4 parts, A, B, C, and D. What is consistent is they will always be graded out of 9 points. So they're always going to be considered to be about the same amount of work. Of course, some are going to be harder than others. Typically, you're going to want to average about 15 minutes per question, but some will be a lot shorter. Like if you have like an area volume one, hopefully that's one you can do pretty quickly. A DiffyQ one might take a little bit longer, but again, averaging about 15 minutes per question. And then what you're probably concerned about is like, well, just tell me how to pass the AP exam. So the multiple choice and free responses are both 50-50. That's going to give you a raw score. The raw score just happens to be out of 108. Why they can just make it 100, I don't know, but it's out of 108. They don't release this every year, but this is the one where I can find the most detailed information. So these cut scores change from year to year, depending on maybe like some years have a harder exam, some have an easier exam. But in 2017 for AB, so again, kind of ignore the BC column, but for AB, to earn a 5, you had to get at least 66% of all the possible points. To earn a 4, you had to have at least 55%, and then the 3 had to have at least 41% of the points earned. That does change. Like I know one year the 5 was as high as like 72%, but it's roughly like get 2/3 of the points and you're going to earn a 5. Which 2 things about that. That I hope feels like a pretty low percent. Like it should be pretty easy to earn a 5. Realistically, though, we know that not everyone who takes the exam earns a 5. So it is still something that you have to kind of study for and prepare for. It is still like a challenging exam, but at the same time, it's also very easily attainable. Last year, just so you know my stats, I didn't have an AB class, but in my BC class, 65% of my students made a 5, and all but one of them passed the AP exam. So honestly, if you've done what you're supposed to do, then I can pretty much tell you're going to pass. And if I don't think you're going to pass, I'll be honest with you and tell you. I'm usually pretty good at predicting the scores kids will make. So that's going to be basically the AP exam. That's what we're going to be preparing for. Things that I have shared, I'm going to have like optional and required stuff. Most of the stuff on this exam info page is either going to be like optional stuff, extra stuff, and then like our day-to-day stuff. So I've shared with you just some general extra practice with some links, like there's like the old 2012 exam. If you're really bad at just taking derivatives and integrals, there's like it's not a Quizlet, but basically the same idea of like practicing those rules. Resources on AP Classroom, in person, and the digital kind of hints and tricks. Stuff you may know tab, I have things that you definitely need to know without thinking too much about. It's kind of like if I just pulled the most important parts of calculus, what must you know? And I think kind of look at that list and like, okay, that's pretty much what's in calculus. We are going to come back to it today, and this is going to be our notes for today. A review of the big theorems, and then a sample FRQ relating to the big theorems. I've shared with you all the quick references, just a blank version of it. So some of you had me all year, some of you didn't, but that would be kind of a good thing to fill in just to make sure you remember the key parts from each unit. I also share with you blank with a link to kind of like the key formula handouts we had. And then under that with important will be kind of like our stuff we do each day. So day 1, day 2, and day 3 have been shared with you so far. Some of you might just be asking like, all right, Mr. Brown, just tell me what's required bare minimum. Hopefully you're going to do more than you need to do well in the AP exam. But if you're concerned about like the actual grade, anything I'm grading is going to be on this graded practice tab or explained on this graded practice tab. So first off, as I shared last week, I need everyone to take their unit test. There's a few people here who kind of dipped out on that unit 9 test. So you're either going to recover it or you're going to take the final. But everyone else did take that unit 9 test. The practice that I'm grading, so I'm going to count it as a quiz grade. I am not the type of teacher to give you like an 86-page practice and tell you to do all of it. We are not going to have like a 3-day mock exam and just take the time to do all of that. Because ultimately, like there's ways to do well in the exam without having to do a bunch of busy work. So I often find that like once practice turns into busy work, then that's what it is. It's just busy work and something to get done instead of something that's like actually going to help you do well in the exam. So at a bare minimum, what I want you to do, there's some practice multiple choice questions, and I want you to choose 5 questions from each page. What those look like, they're under the multiple choice tab. I have them divided by topics, so we have like limits, we have intro to derivatives, applications, basics of integration. Pages A through H, each page has roughly 10 questions on it. I'm asking you to find 5 of them that you know how to do. The answer key is at the bottom, upside down, so you can kind of easily check yourself as you do it. I don't have worked out solutions for all of these, but I chose these from older exams, so like if you just Google the first few words in it, like you're gonna find the worked out solutions online. Like they're there if you need them. Obviously, I'm here to answer questions. So bare minimum from A through H, you need to choose 5 questions from each page. And then bare minimum from the free response, I do want you to do all of those. Right? I try to choose just 1 question of each type of possible free response that you could find. There might be some graded classwork that we do, but ultimately it's just like, hey, if you do all this practice, I will give you a 100 as a quiz grade, and then go and find your lowest quiz grade and drop it. When is it due? It's due before your AP exam on May 4th. If you are doing the June one, I still need to have time to like finalize grades, especially if you're a senior. So the due date for that is going to be May 17th only if you're taking it in June. For the free responses, I did share some other things with you. So I shared with you a list of the possible free responses the AP exam kind of uses. Those are in order of most likely to be on the AP exam to least likely to be on the AP exam. And then you can kind of see the totals for the different years. I can pretty much guarantee that your exam is going to have an accumulation problem. That's like the rate in, rate out. Area and volume has actually been less likely, especially in recent years, you can kind of see. It's about time to use another area and volume, so I'm kind of predicting one of those to be on the AP exam. And then definitely I would predict the position, velocity, acceleration. All the other ones are going to be like one of those remaining ones. And I try to choose at least 1 question for each type for you to kind of practice with. You have until the AP exam to get it done. To kind of help yourself be paced out about it, under each daily kind of agenda, I will tell you which parts to focus on. And if you do those each night, then you're basically going to finish in time and be ready for the AP exam. So like tonight and tomorrow, I'm going to say focus on A and B on a multiple choice. That's going to be limits and interderivatives, and then the first free response question. Do a little bit each night, and you're going to be ready for the AP exam. Any general questions right now about the AP exam or about like what's required? Yeah.
When is the AP exam?
Say again.
What date is it?
It is, for most of you, you're taking it May 4th, and it will be a morning exam. So yeah, May the 4th be with you. Sorry. But yeah, like we'll be ready for it. We'll have plenty of time to review. And my plan again each day is like some days we might do just like 2 problems. We might do a free response question. Like tomorrow I'm going to reteach a topic that a lot of people who didn't have me first semester need to know. But especially as we get closer and closer to the AP exam, it's just going to be a lot of work days, and I'm going to rely on you asking questions to make sure you're learning and practicing what you need to do. What I did want to do today is under the exam info tab, stuff you must know. There's some big theorems that we know shows up in calculus, and I did just want to go ahead and review those. Do a sample FRQ, and then basically that's where I'll stop at today. So again, this is on that tab. If you're looking and want to follow along, exam info under stuff you might know, the big theorems with sample FRQ. I know some of you are worried because you didn't have me first semester and you feel like you maybe missed out on some stuff you could learn. The AP exam, so it is evenly weighted between the semesters, but honestly, a lot of the bigger topics are covered second semester. So like, I don't want to say the AP exam is mostly second semester stuff, but a lot of like the free responses and stuff that's weighted a little bit more heavily will be from second semester. So some of the big theorems that we have in calculus to look at. The first one is the first fundamental theorem of calculus. We covered this one. Actually, all these came from Unit 7. The first FTC tells us that when we have a definite integral, we can find the antiderivative, and we're going to plug in the top value minus plugging in the bottom value. And again, I'm using that capital letter F to represent the antiderivative. But there's different ways that we can kind of represent the first FTC. There's the rewritten one that can help you find a value. The rewritten one is when you have an initial condition plus the integral from the initial condition to what you're trying to find of the derivative. And then a lot of these did also show up in those word problems. Like when I say what's the integral of a rate of change, an integral of a rate is going to give us the net change in the amount. Same thing with that rewritten version of the first FTC. We often use that to help us find some ending value. This is often with those like rate in, rate out problems. That one in words is like we have the starting value or the initial condition plus the integral from the start to the end of the derivative, which we know is a rate. So that was the first FTC. That's kind of like one of the big overreaching ideas that we have in calculus. The other kind of one that we have, similar name, so we have the first FTC. We also have the second FTC. The second fundamental theorem of calculus, I have just found experience. If a student's going to forget one of the big theorems, it tends to be this one for, I don't know why, but it usually is this one. The second FTC informs us how we're taking the derivative of an integral. The derivative of an integral, they cancel each other out, but we know that we always have like the common case and the general case. The common case is when you have just a number on the bottom, and then when you have just x up top, and it states, hey, the derivative cancels out the integral, so just replace the t with the x. That's the easy one. That's going to be the common case. We also have the general case where we have more than just x and more than just a number. And again, if people forget something, I have just found that tends to be this formula. Not sure why, but that's the way it is. Its formula, the integral cancels out, we plug in the top, times the derivative of what we plugged in, minus plug in the bottom, times the derivative of what we plugged in. And then some of the other kind of big theorems that shows up a lot, and that's kind of just good to know, and slash I'm also reviewing for this free response that I want us to look at, is we have two mean value theorems. I have the mean value theorem for derivatives, and then the mean value theorem for integrals, and then the IVP. Didn't include Rolle's theorem, like it is a thing, but honestly, if we're reviewing like most important, these are going to be the big theorems that we have in calculus. The mean value theorem for derivatives is going to require your function to be both continuous and differentiable. Whereas the mean value theorem for integrals, we're not taking a derivative, so it only requires your function to be continuous. Both of these are based off of a formula that you would want to know. The mean value theorem for derivatives, to review this one, it basically states that somewhere on a graph, the derivative is equal to the old school traditional slope. And that's how I think about it, is where the derivative is equal to the slope. And again, another word for slope is, of course, the average rate of change. And then we also have the mean value theorem for integrals. It also has a formula, also a good formula to review. And this formula is the function is equal to the average value, where the average value formula is basically the integral divided by the start minus the end. So again, in words, I think of this as the function is equal to the average value. And good just to review that average value formula anyways. And so again, with the mean value theorem for derivatives, we don't have to state for derivatives. If I just say mean value theorems, that is good enough. And if I just say mean value for integrals, I have to be clear to state for integrals. And then the last big theorem that we have, and then we'll look at a sample FRQ, is going to be the intermediate value theorem. The intermediate value theorem only requires, again, your function to be continuous. And it often talks about the existence of a y value. So for example, if you know the starting point and you know the ending point, then I think it's pretty logical every y value in between has to exist. So we often think of this as there's some c in the interval a to b where f of c is between f of a and f of b. And there's different ways to write that. I'm going to stick to just kind of like the verbal way, and then we'll go ahead and look at an example. So again, when it comes to doing these problems in calculus, we often want to approach them, and like when I read a problem, sometimes I just think about like, hey, what is this problem really asking me to do? Like, what is the topic? What is the knowledge that's kind of asking me to kind of look at? So I chose one question that kind of hit all the big theorems in one for the most part. That came from 2007. But before we do that, questions on any of that? You have one?
My pen's not working. Do you have an extra?
Yes, I have extra batteries. Mm-hmm. Is that what you need?
Yeah.
So when I look at a free response question, just so it'll give you some hints, I think there's like some good testing strategies you want. Every free response question on the AP exam will always be graded out of 9 points. Like no matter what, it's always consistent. There's always 9 points. Typically there's going to be a part A, B, and C, and D. If there's not, either way it's going to be 9 points. If you're trying to earn the 5, whichever one it is, what percent of that 9 should you try to be getting for every problem? All of it, clearly, but we'll look at the cutoff scores. What percent gave you a 5 on the AP exam? 66%. So like my thinking when you do a free response question like, obviously you want to get as many points as possible because there's going to be harder questions and easier questions. But if you have a goal to get 5 points on every free response question, you're probably going to get a 5 on the AP exam. So when I look at a free response question, think of it as like a fun little treasure hunt. There's 9 points out there. You need at least 5 of them for all those questions. Some of them will be easy, like you do it, you're like, oh man, I think I earned like 8 or 9 points on this one. Some will be harder, you're like, I think I earned maybe 1 point if I'm lucky. So of course you want to like get as many points as you can. Some strategies I will say on the AP exam, especially if there's a part A, B, C, and D, most students are going to get part A. Most of the good students are going to get part B and C. Very few students will get to the part D for either 2 reasons. Either they run out of time or D is often the hardest one. Doesn't mean it's always the hardest one, that's not really a written rule, but typically if you look at the stats, part D is going to be a harder problem. So one suggestion I tell you on the AP exam, especially for some of you who might be a little bit slower at kind of doing calculus, when you're doing the AP exam, just worry about doing A, B, and C. Like, especially when you read part D and you read it and you're like, I don't know what the heck this is saying, don't waste time trying to figure it out. Like, you can make a 5 and skip every single part D on the free response questions. That does rely on you, of course, getting like enough free responses correct and enough multiple choice correct. But like, if you're a good student and you read part D and you're like, I don't know what this means, just skip it and save it for the end when you can and focus on the part that you know how to do at first. So even when I typed in this problem, like you can kind of see, like I just went ahead and just left off part D. Not that it's impossible, but like, it's just not worth getting. Some people just never get it. So we're just going to focus on A, B, and C, which everyone is going to be able to understand. And looking at time, I got plenty of time. So when I read a problem, we've been doing free response questions all year for homework. We're going to think about now, though, is there's 9 points to get. I took off part D, so there's actually 6 points to get, but there's points that we want to try to get. Always pay attention to what they give you. This one, they give you a table. In calculus, there's 3 ways they'll represent a function. They'll give you a table, they'll give you a graph, and then they'll give you function notation. You'll never have more than 1 table problem on the same exam. You'll never have more than 1 graph problem on the same exam. So this is going to be the table one they use. Always read the words. There's often going to be key statements that are going to be important that you may or may not have to talk about. So I'm going to pull out the keywords. Again, if I have to justify an answer, we might need them. It tells me that f and g are differentiable. It tells me g is increasing, and we have this function h created by f and g. So let's go ahead and start answering these questions. And again, when I try these problems, I honestly like look at the question, and before I even jump into it, like ultimately know an AP exam is testing your knowledge of calculus. So like what skill are they testing? And that can kind of help you approach the question. So looking at A, it says explain why there must be a value r, for r being between 1 and 3, such that h of r is equal to -5. Where the r is written, I know that r is basically an x value. What calculus topic or idea is that question basically testing a student's knowledge of? The IVT is talking about a y value. It's testing your knowledge of the IVT. Knowing that can kind of help me form my answer. It is talking about the function h. So if it is testing my knowledge of the IVT, I don't need to call it by name, but I basically need to figure out, hey, what's the starting y value and what is the ending y value. So let's go ahead and do that first. We want to find the starting y value, which is going to be h of 1. I also want to find the ending y value, which is h of 3. Well, what is h? H is f of g of 1 minus 6, or f of g of 3 minus 6. And there's not really calculus here right now. We just need to evaluate those problems. That first one, if I'm doing h of 1, well, I need to find f of g of 1 first. Well, what is g of 1? G of 1 is 2, so that's going to become f of 2 minus 6. What's f of 2? F of 2 is 9. 9 minus 6 is 3. So there's my starting y value. Now I want to find the ending y value. G of 3. G of 3 is 4 minus 6. F of 4 is -1 minus 6, giving you -7. Making sure we haven't messed up. Explain why there must be a value where h of r is equal to -5. So it's telling me that there is. Looking at those y values, does it make sense that we have crossed through -5? Yes, we know we did everything correctly. So let's go ahead and answer it. For theorems, we don't have to give it by name, but we do want to go ahead and explain it. So this is the IDT, don't need to mention it by name, but what do we need to state clearly about that function h? So this IDT, we really only need to say that it's what? Continuous. It doesn't need to be differentiable. You wouldn't lose points if you said it was, but you would need to say that it's continuous. So we would simply have to state h is continuous. And we see that the smaller one is h of 3. H of 3 is less than -5, which is less than h of 1. And on the rubric, again, I printed it out, that is basically all you would have to say. I'm not okay with that answer, like I have seen some years where they required a bit more of a justification. So even though in 2007, they didn't require it, I would have added something h is continuous because f and g are differentiable, which implies continuity. I know some years they require that. I guess some years the master grader decided it wasn't important. I would use it kind of just to be safe. And again, you wouldn't have to use all those math symbols. If you just said like -5 is between 3 and -7, that would have been fine as well. Points, again, we're on a treasure hunt trying to get as many points as possible. 1 point in identifying the 3 and -7, and then 1 point for some sort of correct justification. So if your goal is to get 5 out of 9 points, well, we already have 2 out of the 9, almost there. Questions on that one? All right, so let's go ahead and look at B. Explain why there must be a value C, where C is between 1 and 3, such that h prime is equal to -5. What concept or theorem is this one testing your knowledge of? And your hint is I see h prime there, derivative. And there's your options. There's the option. Mean value came for derivatives. Why does it test my knowledge of that one? That's the one that talks about f prime of c. So what does it mean? It means that we have to find the derivative equal to the slope. So if I'm approaching this problem, if it is testing my knowledge of the mean value theorem for derivatives, what do I basically need to find? I need to find the slope. So let's go ahead and find that slope. The slope is the change in y over the change in x. Don't waste your time. We already found h of 3 and h of 1. That was from part A. H of 3 was -7. H of 1 was 3. That gives me -10 over 2. That 3 looks like a 5, which is -5. Hey, that's what we expected. Now we just need to justify our answer. So explain why this is true, basically because h is differentiable. I'll say since h is differentiable, there is some c in the interval from 1 to 3, so that h prime of c is equal to -5. Notice my statement wasn't anything that I kind of created on my own. I literally took the statement and the question and just like flipped it around. So like I basically just used the question to help me form my answer. The points for this one, where they came from, you got 1 point for showing that the slope is -5, using your answer from part A, and then you got another point by just being able to explain your answer of how you knew that had to occur. So again, a goal is 5 points out of 9, hopefully more. We're already at 4. And we're just going to do one more question, and that's where I'm going to kind of wrap up things today. I took off question D. I left just part C on here. Part C says, let W be the function W of x, where W of x is the integral from 1 to g of x of f of t. And we want to find the value of W prime. So we're basically taking the derivative of W, and W is an integral. What theorem is this one basically testing our knowledge of? Which one talks about taking the derivative of an integral?
Common piece?
So it is a second derivative, the second fundamental theorem of calculus. Could be the common case, could be the general, we wouldn't want to look at it, but that's basically what this one is asking us. Let's talk about some clues of how I know this is a second FTC problem. The reason why I know it's a second FTC problem is W is an integral, and it's asking me to find the derivative of W. So whenever you're taking the derivative of an integral, big idea, this is the second FTC. So let's find the derivative first. Let's find W prime of x. Is this going to be the common case or the general case? General. We have more than just x at that top. It's g of x. So let's use the formula. Plug in the top times the derivative of what we plugged in minus plugging in the bottom times the derivative of what we plugged in. What's the derivative of 1? 0. So yeah, that part wasn't that important. Times 0, going to go away. And then we want to find W prime of 3. That's going to be f of g of 3 times g prime of 3. And then just use the table to figure all that out. G of 3, I already forgot. G of 3 is 4. So we have f of 4 times g prime of 3, which was 2. And then we have f of 4, which was negative 1 times 2. And again, that came from the table. I just haven't memorized. That's the third time I've done it today. But negative 1 times 2. So we can see that W prime of 3 is equal to negative 2. So I like that problem because it did hit kind of a lot. Like we had IBT, MBT, second FTC. That part D I took off was basically a tangent line of the inverse, but ultimately I just want to kind of focus on the theorems one. But that's where I was also going to kind of wrap up today. So like each day we might do like a free response question, we might do some practice multiple choice, I might have like a different type of activity to do. We might practice our derivative rules, our integral rules, and making sure that we're ready and prepared for the AP exam. Of course, you have to kind of do your part and make sure you get like that necessary practice completed. Any questions on that problem? Yes, Ronnie.
When you did the multiplication by g prime, that wasn't the what's it called, chain rule, that was because of
It is a chain rule, but it shows up
in
in the formula. Like that is the chain rule within the second derivative. That's where we did like plug in the inside. That's the times b prime in the formula. So what I want you to do, and again, I'll try to tell you what I want you to do kind of for homework so you don't have to like cram, because cramming is not something that really works for the calculus exam. Tonight for homework, and it's going to be the same thing for tomorrow night, I just want you to focus on, not that, I just want you to focus on those multiple choice problems, part A and part B. Again, you only need to do a minimum of 5 on each page. Want more practice, but like you only need to do 5. So 5 limit questions, 5 integer derivatives, and then also see how much you remember from that part B. Again, do a little bit each night. Typically in class we will have more time to work. I won't be talking the whole period every day. But again, my plan is I have it spaced out to where if you do what I tell you to focus on each night, then basically you'll have all the practice you need of all the topics you need to know before the AP exam. Questions on anything? All right, so y'all can go ahead and get started. I'm here to answer questions. Definitely if you're at home, ask the questions. Especially some of you might realize like, oh, I don't remember these limits, but I promise you all that stuff's going to come back to you as we begin practicing them. But yeah, y'all can go ahead and get started and all that. Yeah.